Students, welcome back to a physics online class. So in previous videos we had discussed on Joule's law of heating. So in case of that Joule's law of heating, so already we come to know about that neat applications related to Joule's law of heating, and bulbs are connected in series and bulbs are connected in parallel combination. Today we will be discussing on grouping of resistance. So in case of that grouping of resistance, so number of resistance I would like to connect in a series combination, or otherwise I would like to connect in a parallel combination. If you connect in series combination, what will be its effective resistance? If you connect in parallel combination, what will be its effective resistance? I need to find out here. So today let me start with a grouping of resistance. So in case of that grouping of resistance, I will consider that series grouping here. First I will consider series grouping. So in case of that series grouping, so series connection means end to end connection I said. So end to end connection means, for example, this is one resistance, so one end of the resistance is connected to other end like that. So these kind of combinations, so I will consider that a series combination of the resistance here. So in that series combination, so I will name that end to end connection I said. So for example, this is resistance R1 and this one is resistance R2. These two resistance are connected in a series combination here, so to a potential difference, or voltage is, for example, 5 volt, whatever. Now what will be the effective resistance? So R of S is equal to what? So R1 plus of R2. So in case of series combination, effect resistance is greater than the individual here. So in series combination, which of the quantity will be remain same? So in case of that series combination, current is remains same. So total potential difference is equal to sum of the individual. So it means that I want to determine the branch potential difference here. So what is the potential difference across the first resistance, and what will be the potential difference across the second resistance? I need to find out. So in order to determine the branch potential difference, so V1 is equal to, so total potential and resistance of the same branch. So I want to calculate that potential difference across first resistance. So V1 is equal to V into R1 divided by R1 plus of R2 here, and potential difference across second resistance, what is the formula? Total potential difference and resistance of that branch divided by R1 plus of R2. So look at here, I want to calculate the branch potential difference. So in order to calculate the branch potential difference, I need to use these equations here. So now in case of that parallel grouping, so in case of that parallel combination means, so connection made between the two common points, so that is parallel combination. Parallel combination. So in case of that parallel combination, so two or more resistance are connected between the two common point. I will name it as a parallel combination. So look at here. So in case of that parallel combination, so let me consider two resistance here. So these two resistance are made connection between the two common point, or you may take that more than two resistance, so whatever. So for example, so this one is resistance R1 and this one is R2 here. So these two resistance are connected to a potential value here. So this connection we will name it as a parallel combination. What is the effective resistance in parallel combination? 1 by Rp is equal to 1 by R1 plus of 1 by R2, or otherwise I will use this equation, R of P is equal to R1 into R2 divided by R1 plus of R2. In parallel combination, effect resistance is less than the individual value. So in case of parallel grouping, which of the quantity will be remain same here? So potential difference is remains same. So for example, in that first resistor, current I1 is flowing, in that second resistor, current I2 is flowing. So now I want to calculate the branch current here. So how will you determine the branch current here? So I1 is equal to, so branch current is equal to total current into resistance of the other branch. For example, I want to calculate the current in the first resistor, so I will take that resistance of the other branch here. So look at here, branch current is equal to total current into resistance of the other branch divided by total resistance here. So generalized formula I will take it here. So I2 is equal to what? So total current into resistance of the other branch. So this is R2, other branch means R1 here, divided by total resistance. So this is the connecting formula. So in case of that series combination, so total potential difference is equal to sum of the individual. So individual potential difference, this is the formula. So branch potential difference is equal to total potential difference, resistance of the same branch divided by total resistance. Here branch current is equal to total current into resistance of the other branch divided by total resistance here. So in case of that series combination and parallel combination, so this is the formula to determine the effect resistance in series and effect resistance in a parallel combination. Suppose if that n number of resistance are connected in a series combination, what is the effect resistance in this case? So if that n number of resistance are connected in series combination and n number of resistance are connected in a parallel combination, what will be the effective resistance I need to find out here. So look at here. So if n number of resistance are connected in a series combination, so let me write it here. N number of resistance are in series combination. So if that n number of resistance are in series combination means effect resistance is n into R. So if it is connected in parallel means, so if n number of resistance are connected in parallel combination, so R of P is equal to what? So R by n here. So look at here, n number of resistance are connected in series combination is n into R, in parallel combination, so that is R by n. So if suppose what is the ratio of n number of resistance are connected in series and to that of parallel, so R of S divided by R of P here. What is the ratio here? Ratio of that number of resistors are connected in series to the parallel. R of S is what? N into R. R of P is what? R by N here. So this term will getting cancelled out. So R of S divided by R of P. So that is equal to N square by 1 or N square here. What is the value here? R of S divided by R square is equal to N square here. Suppose now, so I will consider one wire. So that wire I will break up into a n number of identical pieces. Then what about the effective resistance here? So I will consider one wire here. So consider a wire of resistance. So this wire having certain kind of resistance. Consider a wire of resistance. Resistance R is cut into n number of pieces. So this resistance is cut into n number of pieces and it is connected in parallel. So in which connection? So in which manner I will connect these resistance here and connect in parallel. Then effective resistance value. So R effective is equal to R divided by N square here. What is the effect resistance here? Effect resistance is equal to R divided by N square here. So now look at here. So in case of that grouping of resistance, so I will give that, so equivalent resistance in series combination value and equivalent resistance in parallel combination value. I want to calculate that individual resistance value. So look at here, let R of S and R of P be the equivalent resistance. R of S and R of P be the equivalent resistance in series and parallel. Then individual resistance value is, then individual resistance value I need to find out. So what is the here? Individual resistance. So R1 is equal to 1 by 2 R of S plus of square root of R square of S minus of 4 times of R of S into R of P. So they will give that effect resistance in series and effect resistance in parallel combination value. I want to calculate that individual resistance. So for example, R2 value 1 by 2 R of S minus, just I will change the sign here, minus square root, remaining thing will be same, R square of S minus of 4 times of R of S into R of P here. So this is the connecting formula. So for example, they will give the question like so: effect resistance in series combination is 12 ohm and in parallel combination is 3 ohm. Calculate that individual resistance value. Which thing I need to calculate here? Individual resistance value. So this formula I need to use here. So look at here, R of S value and R of P value they mention 1 by 2. R of S value is how much? So that is 12. So square root of R square of S. So 12 square means 144 minus of 4 into R of S value is 12, R of P value is 3. Then what will be our answer here? 1 by 2, 12 plus of 144 minus of, so 12 into 4, 48. So 48 into 3. So again 144. So this value is 0. So R1 is equal to what? 6 ohm here. What is that R1 value here? R1 value is 6 ohm. Then what about that R2 value? Just sign is different here. So here minus. So R2 value is also 6 ohm. So in order to get that 12 ohm effect resistance in 12 ohm, and so 12 ohm we will get in a series combination. For example, 6 ohm plus of 6 ohm. So R of S is equal to what? R1 plus of R2. So 6 plus of 6. So that is 12 ohm. So in series combination you will get this combination as a 12 ohm. In parallel combination, so 6 ohm and 6 ohm resistance if you connect in a parallel combination. So R of P is equal to what? 6 into 6 divided by 6 plus of 6, 36 divided by 12. So that is 3 ohm. So in parallel combination, so you will get that 3 ohm. So 6 ohm and 6 ohm resistance. If you connect in series combination, you will get 12 ohm. If you connect in parallel combination, you will get that 3 ohm resistance. So this is the way to calculate the individual resistance if they given that effect resistance in series and parallel combination. So let me look at that next one. So in case of that cube, so that cube is made up of 12 identical resistance. So I will construct one cube here. So while constructing the cube, so I will use that 12 identical resistance. So let me draw one cube here. So this is one cube. Okay, so this is the cube I will consider. So in order to construct this cube, so I will use that 12 identical resistance here. So for example, this is A, B, C and D, E, F, G and H. So look, let us assume that these are all resistance here. So these are all resistance here. So look at here. So by using that 12 identical resistance, so I will construct one square here. So like that. So I will construct one square here. So now let me find out that, so each resistance value is R ohm here. So each one value is R ohm. So then I want to calculate that. So effective resistance here. So effective resistance I want to calculate that effect resistance in a different cases here. So for example, I want to calculate that effect resistance between the longest diagonal. So in these diagram, which is that longest diagonal? So look at here. So between E and C or between A and G here. So these two are longest diagonals. So I want to calculate that. So net resistance along longest diagonal. So what are the longest diagonals here? So E to C here. So one end and another end, E to C, and another longest diagonal is, for example, A to G here. So what is the connecting formula here? So in case of that effect resistance along longest diagonal, so that is, so 5 by 6 into R. So what is the connecting formula here? So effective resistance along the longest diagonal is 5 by 6 into R here. So for example, next I will calculate that. So net resistance along the diagonal face here. So diagonal face means what are the diagonal faces here? So for example, between that B and G, or between that F and C, or between that A and C, or between that B and D, or between A and H, or between that E and D. So these are all diagonal faces here. So along diagonal face, along diagonal face here. So along the diagonal face 3 by 4 are here. So what is the effect resistance along the diagonal face here? So for example, what are the diagonal face here? So A to H is one diagonal face. For example, A to C I will take, or B to G, so whatever. So along the diagonal face I want to calculate the net resistance along B to G here. So in case of that cube is made up of so I will construct the cube by using a 12 identical resistance here. So now I want to calculate that effect resistance along that longest diagonal here. So as well as, so diagonal face I got that. So third one is along this side here, along the side. So side means, so resistance between AB, or resistance between AD, or resistance between E and H here. So for example, A to D, E to H, whatever. So that is 7 by 12 R. So look at here, in case of a cube, that cube is made up of 12 identical resistance here. So now let me calculate that resistance along the longest diagonal, resistance along the diagonal face, so resistance along the side here. So these are all the connecting formula I need to use here. So hope you are understanding here. So next one, so in case of that grouping of resistance, suppose if they give that infinite number of circuits here, so how to solve that effect resistance between the 2 point in case of infinite circuits? So let me use the direct formula for that also. So in case of resistance, so these resistance will arrange in a grouping manner. So it consists of infinite number of resistance. So for example, let me draw on the circuit here. This one is point A. Here that I will name these resistance as a R1 here, identical here. Here on resistance, here on resistance. So like that. For example, here on resistance, and this one is point B here. I will name this one as a R2, this one as R2, this one as R2, like that. So it is in an infinite way. So this one is R3 and R3. Then what is the effect resistance between A and B here? So effect resistance between A and B is, so 1 by 2 R1 plus of R2 plus of 1 by 2 R1 plus of R2 whole square minus of 4 times of R3 into R1 plus of R2 whole to the power of 1 by 2. So look at here. So in order to calculate that effect resistance in case of that infinite resistance, so look at here. Here 3 resistance are there. So R1, R2 and R3 here. So let me find out that effect resistance between AB. So 1 by 2 R1 plus of R2. Next make it as a square, 1 by 2 R1 plus R2 whole square minus of 4 times of R3 into R1 plus of R2 whole square. So this is the direct formula to determine the effect resistance between A and B here. Suppose if the circuit is like so, so it consists of only set of 2 resistance. So this one is R2, then what will be the formula in this case? So in this case I want to find out the effective resistance between the point A as well as between the point A and B here. So effective resistance between the point AB, so that is 1 by 2, sorry, so this one is 1 by 2 R1, 1 plus of square root of 1 plus of 4 R2 by R1. So look at here, what is the connecting formula I need to use in this situation? So 1 by 2 R1, 1 plus of square root of 1 plus of 4 R2 by R1 here. So hope you are understanding these things. So remaining thing will continue next class. So I will give some assignment questions, so follow those assignment.